Our next speaker is Norm McCall, the construction of Skytrawl Urban Observatory. Take it away, Norm.
Okay, my name is obviously Norm McCall. Just a little history on myself. I joined the Astronomical Society London Centre in 2011, and in 2014, I bought my first telescope at age 60, and then I built this observatory in 2017. And after 2 years of trial and error, I finally got my first live view setup working in February of 2020. So this is when I started, and this is the little logo I have for my observatory. So the first question you might want to ask is, why would you want to build a deep sky observatory? Well, an astronomical observatory located in an urban environment, what is it? It's an astronomical observatory located in an urban environment in which city light interferes and prevents visual observing. Therefore, an urban observatory uses a large aperture telescope to capture a lot of light, a high-performance motorized go-to mount capable of precision computer guiding to accurately track objects at high magnification, specialty resolution, high-resolution thermally cooled astronomy cameras capable of capturing long exposure images, and computer software designed to capture deep sky images in real time for display in a 4K monitor. And there's a picture here on the right showing my setup when it was working at night. So starting off this project, you have to decide on what are your design considerations. So the main factors in building my observatory include the following considerations. Budget, how much am I prepared to spend? And what options are available given my budget? And then the next thing is, what are my needs? So for me, it was to be used for visual and for astrophotography, and both. So those are questions you would ask yourself. And then you've got your backyard considerations, like how much space is available and where to locate the observatory in your backyard given skyline considerations. Next, you move on to what are the design criteria. Well, my design criteria included a budgetary cost estimate of about $5,000. An observatory suitable for both visual and astrophotography. I wanted a pier mounted scope, polar aligned and ready to go. I wanted a shed with a warm room capable to enable use of the facility in cold winter nights. And I wanted a secure and dry environment for secure storage of astronomy equipment. And I wanted it to be vermin-free and not susceptible to moisture or mold buildup. And I wanted to have space for up to 2 or 3 if I have some friends come over. And the shed size could be no larger than 8 by 8 feet due to limited space available in my backyard. And I also wanted to have an innocuous appearance to avoid attracting vandals. And I was going to have hardwired AC power with a dual Ethernet connection into the house. I wasn't going to depend on Wi-Fi. Okay, so my design options include a dome roof like a SkyPod brand observatory, a traditional roll off the roof design, or there's also the small storage shed with a scope mounted on a rollout dolly, or a roll-off shed with a fixed pier and a mounted scope. So let's consider each of these options here. So you start with the SkyPod design option, which for those unfamiliar, looks something like this. They come in various sizes. So what's the issue? Well, one of the first issue is cost. You've got complications in rotating the roof. Either you do it manually or you do it electronically, which increases the cost, electrically driven. It's got a very large footprint, and it has appearance that could attract, in my opinion, vandalism. And in my view, it's susceptible to rain leakage in the ones that I've observed, with moisture condensation and potentially vermin issues. And there's no way to incorporate a warm room. The next option was a traditional roll off the roof design option. And they look something like this, where the roof rolls off of the shed. And you can have a warm up room or a heated room inside of that, but it starts to make it bigger. This is a traditional design option for do-it-yourself built observatories. The estimated footprint, unfortunately, is 14 by 8 with the addition of a warm-up room. The total length of everything becomes 16 feet, including the track, which is a lot of real estate, and up to 30% of my backyard. And if built with cedar, it could be very expensive. And another option is as I mentioned earlier, is the rollout dolly design option. This is typically used as a small storage shed with limited space in your backyard. And you also have a lightweight scope mounted on a rollout dolly. And unfortunately, it requires the user to polar align the scope for each use. The stability of the scope on the cart is questionable, especially if it's a heavier scope. And it requires a cement pad to prevent the ground from heaving due to frost. If you want to roll it out over an uneven surface, it's kind of a problem. So let's consider the roll-off shed design options. And this is the one here, where you roll the shed off of the telescope. You'll notice in the picture, you notice in the picture, the shed is sitting on a track mounted on a cement slab. So it has a fixed pier, which I like, with a roll-off shed. The question is how to design a low friction and maintenance-free track. Oops, so it's happening. There we go. And then the question is how to support the front of the shed with the roll-off pier. If there's a floor in here, there's an issue of how do you provide this to open up and allow the scope to come out. You'll see that in other pictures shortly. It does offer a fixed pier and a permanently aligned scope, which is good. It provides a warm room for cold weather use. And this is the best design fit for my design criteria. So here's some examples of roll-off sheds, and this is some of the pictures I captured online, or I found online. There's this design here. And I'm talking here about the floor opening and how do you support this. In my opinion, I don't know how this is supported, although it seems to be supported with bolts mechanism. And but it is an issue and has to be resolved. This is another example. In this case, they just left the opening open for where the shed rolls on. There's this kind of a design, which is a mini design. And in this one here, the shed is sitting on caster wheels that can roll off. It's not going to work very good in the wintertime. And this one here, I'm not too sure. I think this is the one that folds over. I'm not too sure. And this one here is something you just dismantle and move it out of the way. Okay, so my observatory design selection was the Vision 8x7 vinyl storage shed, which is sold in Toronto. And I went there and picked it up myself as a so-called second, which was not a second. It was brand new. There was no deficiencies. It's just how they sell it cheaper directly to the consumer. So the roll-off shed is mounted. The thing I liked about it, by the way, is it's also a 2-inch thick material. So it's kind of insulated for the winter. So the roll-off shed is mounted on a V-groove track. And it is sized with adequate space for the scope, the computer, and for accessories, shelving. It's a good quality Vision 2 extruded shed. is I'm going to design it with an insulated wooden floor, a pier mounted in a lined scope, and it will be heated for winter use. And it is moisture proof and vermin proof. So you start off with the design of the track, and you see the picture of it here. That is the track I had custom welded up for me. First of all, I estimated the weight of the shed between 800 and 1,000 pounds. That is with people inside of it. You know, that was the design criteria. All right. So the design track options, before I had made the decision to build it this way, one consideration was nylon wheels. Unfortunately, they're susceptible to dirt, rocks, and wear. Rubber wheels may split and require maintenance. And if you use a U-shaped track laid on the ground, it will get filled with dirt and have snow buildup. So my solution was this V-grooved steel wheels on a right-angle stainless steel track. And the reason I chose stainless steel is because steel rusts and requires maintenance. Aluminum is susceptible to pitting from sand and rocks that do get on it. And I used 1¼ inch stainless steel angle bracket welded to a flat bar, as you see in the picture, and it's maintenance free. So this is how I started construction. It was very hot in the summertime, and I had to dig these holes manually in lovely clay, a lot of it when you dig further down, but this was how I laid it out in my backyard. Now the pier base, I came up with an interesting issue. The hole could only be 42 inches deep, and that was because there was underground, there was the remains of a buried pool, concrete from a pool that we buried. And so therefore the solution for that was I held the pier in place with rebar bonded into the base concrete so that the pier would not shift, move, or crack off that surface. The pier base will use a 14-inch diameter sonotube. And this here is the depiction of the pier, which is here, and the sonotubes. There's 8 of them in total, and I can't remember how the diameter. I think those are 12-inch in diameter. All right, and eventually this here is after I poured it and put down the tracks. Oh, it's 10-inch diameter sonotubes for each track. Okay. The wheels sit directly above the sonotubes on the ground so that they don't bend the track if they're sitting there for an extended period of time. The track is adjustable by screws underneath, so if there's any settling or any issues, I can adjust it for level. It's using Western cedar runners to resist rot, ants, bugs, etc. I'm hoping that will ensure a long life, as compared to pressurized wood in contact with moisture, which will hardly last a few seasons. This is a close-up picture of the wheels on the stainless steel bracket and how they were mounted to the side of the floor. So the floor construction, this here is made of pressurized wood, pressure-treated wood, I should say. All of it is pressure-treated plywood, etc. 3/4 inch plywood top and bottom, 2x6 floor joists, and the side joists here on each side are reinforced with leftover plywood. The floor is insulated to keep it nice and warm and you're not freezing your feet off on a cold surface. I use heavy-duty 3-inch Torx screws and lags to ensure, you can see them here on the side, right here, lagging things together. All right, the electrical wiring is buried in the structure. And I use 2x8 joists on the side. And then I cover the floor with plywood. And the method I used when I'm standing in here to hold this from falling is I use support beams that go up to a crossover header. So these 2x4s here hold the floor at the front when this is cut out, and they distribute the weight to headers that rest on the side posts over here. I hope that makes sense. Okay, it's tongue and groove wood. And what else did I do? Okay, so the shed foundation is as shown here. The front entrance is cut out, as I mentioned to you, and these are the supports that hold up the front when I'm walking in and out. All right. Okay. The pier is 8 5/8" diameter, and it's 32-inch tall, made of steel, and I bought it from SkyPod. And it's mounted on a 14-inch fiber impregnated concrete base. And the pier is removable at the top. You can change this plate if you need to change your mount. So I have done that, and I bought a new plate to be compatible with a new mount. And the pier itself is filled with sand to deaden any vibrations. And I did remember to bolt it down. It's just sitting in place right there. Okay, so first light, August 2017. This is the day I had a party, and it was first light. That was my first scope that I had at the time. And that was a little celebration. You can see that the electrical wiring wasn't yet working. To connect the wires into the shed, I bring the wire out in the ground over here, and there's a flexible conduit that goes up into the shed. So I can roll it out, and there's two pipes holding electrical wires and the network connection. And this here is what I call first sunrise over Skythrall. All right. So this is a picture of it in use. You can see I've got a bench here and the scope wired up with a camera. And at this time, these wires are, this is the USB wire. I had a problem, which was that the pipe that I'd chosen to connect back the USB cables was too small. And so I end up having to run the wires in and out each time on the ground. So that was one of those little do it right next time. So what's the advantage? It's a great time saver. I can open that thing up in 10 minutes or so, or close it down in 10 minutes if the clouds roll in. It's a double thick wall design, so there's no condensation whatsoever in the winter, and it helps minimize overheating by sun's rays in the summertime. It's easy to open when friends come over to visit. The patio stones underneath provide a clean, dirt-free walking surface. Okay, it's totally dry, weatherproof, and vermin-free enclosure. I constructed something like an apron that fits around the telescope when the door is closed, and that keeps any animals from climbing in and making a lovely home in a warm place. There is no water or moisture condensation issues, and the insulated floor eliminates any dampness issues associated with a concrete floor. And there's adequate space to store accessories. And the computer is set up and ready to go at any time. And the equipment is secured from vandalism. So these are just some of the things, pictures of inside the observatory. I've got red lights on the ceiling. I've got a Windows 10 Pro. And the reason I use 10 Pro is because it allows remote desktop. It's got a hardwired Ethernet connection into the house, and got a bunch of 4-watt red lights on the ceiling. And these are the computers, and I got storage shelves there. There's drawers, I should say, and shelves to hold stuff. And that's how things are packed. And this was the little mechanism I used here. That little box I built in that keeps any animals from climbing in the hole and finding a nice place to live. And I got a storage rack here like so. And I run there's my 12-volt battery running all the time for the system. Conclusion? What's the conclusion? Okay, it took an estimated 120 hours of work to complete the observatory. The finished cost was approximately $6,500. The heated room with the insulated floor provides a great work environment. The 8x7 shed size is perfect for size. Areas to improve, I would recommend, I only used 3/4 inch PVC. I should have used 1 inch. I would use in a future design 3-inch diameter V-groove wheels instead of 2¼ inch. It would make it rolling the shed off a bit easier with snow and ice. And I would recommend a 200 CFM or larger exhaust fan in the summertime, just to help keep the temperature down. And if you have any questions, you can contact me here.
Thank you very much, Norm. Enjoyed your presentation. I have a similar make of shed observatory, but I converted it to a roll-off.
Okay.
I did a presentation a long time ago about it. Do we have any questions for Norm?
Yes, we do. First, let me start with a comment from Guy Yanez. Maybe we should also consider local regulations and not bothering neighbors unless invite them over. I tend to agree. But he also follows that up with a question. What grease should we use on those rails, if any? And Frank Dempsey essentially repeats the question with, should grease be used with the wheels?
Well, yeah, that's a good question. You know, the thing is, I bought these wheels online from eBay or not, somehow from China, and I opened them up to grease them. So yes, so the answer is I use grease to grease them, and I found that the seal bearings were pre-used, and the grease in there was black and dry and hard. So they were selling a used bearing in the wheel, and they weren't expecting people to look inside. So I had to go out and buy replacement bearings that are sealed, and I just packed them with grease.
Leo to CAF says, looks a bit like the Royal sheds that used to be available. Where did you buy the shed?
You can buy this at Home Depot, or just look up Vision Systems or whatever. They're in Toronto and Scarborough. It's not Markham. I can't remember which part of Toronto. Near the airport, if I recall, but it's hard to remember. Just look up Vision. They sell that shed at Home Depot, but they sell it for $1,200, and I got it for $900 or something.
That's all the questions.
All right.
Okay. Thanks again, Norm.
You're welcome.